Okay, let's keep going with the talks. We've got 4 talks to go. And our first one, Jen has come up from Melbourne, and I was delighted to speak to Jen earlier in the week and hear that she is now Dr. Jen. So a round of applause for Jen. One of Jen's supervisors was Deb King, a Delta stalwart and first year in maths creator. And unfortunately, Deb's not here this week because she's about to become a grandmother and didn't want to leave. It's a reasonable reason, but the baby's not due for a couple of weeks. So I called her piss week, but anyway.
All right, thanks everyone.
Okay, so over to you, Jen.
Hi everyone, so my name's Jen. I'm presenting the last little piece of some of my PhD research, which I finally finished earlier this year. Deb King and Mark McLean were my supervisors. Mark is in UBC in Canada, and most of you should know Deb. So as we were coming in, actually, before I start, can I get a thumbs up and a thumbs down of how much do we know about comparative judgment? Just so I know how much detail to give. A strong yes. Okay, a big C of no. All right, so for those that gave me a yes, my apologies. I'll go into some detail. So today is about comparative judgment, and I'm going to talk about it in relation to peer assessment. And I'm going to get you to pretend that you're students and you're going to do a comparative judgment for me. So imagine that you have done this question, solved that rational inequality, and you've submitted it. And now I'm going to show you a whole bunch of examples that other students have done. All you have to do is just click on the one that you think is better. I'm not going to tell you what better means. It's up for you to decide. So have a quick look. Left or right? When you make a decision, give me a pointing to the left or a pointing to the right. Sure, have a chat with people around you. Absolutely. There are no correct answers here. You're welcome to talk to people around you. All right, give me a pointing left or pointing right. Which one do you prefer? Okay, we've got predominant left. Anyone for the left? No takers for that one? Interesting. Sorry? What's your pet hate? All right, cool. Students were probably split 2/3 the right, 1/3 the left. But the point is that it does not matter what decision you make. There is no right or wrong decision. So here are some of the reasons students gave. They didn't like the left one because that student didn't understand it. They like the left one because it's quicker. They like the right one because it has diagrams. Both were bad. And then they just kind of flipped a coin. They like the right one because it's correct. They like the right one because it's easy to understand. Or they like the left one because that's how they would do it. So I collected a whole bunch of data about students' reasons for picking one over the other. And I just want to make this point right up front that I made no judgment about students' judgments. I just wanted to know, what are they actually looking at? Where are their eyes going? Okay, so even though some chose the left because they said it was correct, it's not. I went, cool, that's what you think, great. I now know that you're interested in accuracy. So you've now just done a comparative judgment, congratulations. So looking at some of this comparative judgment literature, some unis, particularly Melbourne, was having a play with using this, and Tanya over here has done a lot of work with comparative judgment as a methodology for analysing data, so you might want to talk to her as well. I'm interested in, was that of any use to the students? So traditional peer assessment, you might look at one solution one at a time. and you might maybe give it a grade based on a rubric or give it some feedback, whatever. Here we're doing 2 at a time and just deciding which is better, no rubric. Looking at existing studies, there's not a lot. There's a whole bunch of work that's come out of the US in the area of design and technology, where they typically compare students' design artifacts. And they found that if students use comparative judgment as peer assessment versus doing it 1 at a time, the comparative judgment group come out consistently with consistently better products at the end. Some other studies, particularly in essay writing, there's no real relationship yet whether one approach is better than the other. What about maths? So some spoilers ahead. I did 2 studies for my PhD. Study 1 was a very small study. Study 2 was a large one. Study 1, the comparative judgment students came out better in terms of performance if they did peer assessment in pairs or peer assessment 1 at a time. But in study 2, which is my large scale one, there was no difference. So I think what we can at least take from this is it's not doing any harm. And the comparative judgment students are either performing as well or sometimes better than sequential, but it seems to be very consistent in design technologies. So it seems to be working well for that subject. So I was more so interested in why. I'm going to take the assumption that it probably is good, and I wanted to know why. And there's just nothing out there on this. So some suggestions with really not much data to back it up. Some people have suggested that students really enjoy it, so maybe that's why they do better. Students tend to engage in self-reflection, self-regulation when they do it, because they see how other students do it and they go, oh, that's how I should have done it. Maybe it's something to do with the actual process of comparing, but they just kind of say maybe it's that. And then there's this final group at the bottom that I'm going to focus on, which is maybe when you compare, it shifts where you look and you start to look at different things. And again, we've got no correlation causation here, just suggestions from the current literature. So here is my research design. So 2 studies. Study 1 was small scale, which then got just completely disrupted by COVID, so I had to completely redesign, which is fun. Both studies were pre-task intervention, post-task. On the left, I had secondary and undergraduate students. Secondary were 16, 17-year-olds. And I had students split into 2 groups. You looked at the same set of worked examples, but you either did them 1 at a time or in pairs. And I had them think aloud. So they were just talking to me how they were going to make a judgment. So the 1 at a time group gave them a score out of 5, and the pairs group just had to decide which was better, like what you guys did. On the right was study 2, calculus 1 students. Nice opt-in, which had 532 students join, which is great. Same thing, pre-task intervention, post-task. Instead of think aloud here, I had them write written reflections. So they did the peer evaluation and then wrote how they made their judgments. And that's what I used as my data set. But here, because I had such a large sample, I was afforded the luxury of doing 3 experimental groups. So I had the 1 at a time group, and then I had my compare group, but I split them up. And I had one group where I showed them pairs of work where they were as similar as possible. And then the other compare group, I paired my work so it was as different as possible. So I just wanted to see, is it the comparing or is it something to do with how the solutions are paired up that does something? Questions on that before I keep going? Okay. So here's just an example of how I coded my data. So this is an example from study 2. So they've got a written reflection and they were comparing these 2 solutions. So this is the aligned pairs group, and you can see that those 2 solutions are quite similar. They've used the same approach. And the student has commented that the student on the left has images. They answer it well, but the solution on the right has sentences. Words was a big thing. Solutions that use words was a really big thing for students. And so I coded them up into what did they look at and whether it was a positive or a negative statement. So was it something they liked about it or something they didn't like? So in terms of what did they look like, I had 4 categories. Communication was sort of anything to do with how they expressed their reasoning. Might have been layout, a heading, words, sentences, a graph. Accuracy was whether they were looking at, was the solution correct? Was there an error? Anything to do with correct, incorrect work. Presentation down the bottom was non-mathematically relevant content. So was it neat or messy? Was it typed? Was it handwritten? And then there was a third one, which I don't have an example here, which was method, which is just comments about the approach that was used. So the sort of strategies that we used. Okay, so looking at what did they notice? So this is accuracy, communication, method, and presentation. So just looking at these numbers, what this number here represents is out of the 12 students in this group, there are 101 comments about accuracy, there are 146 comments about communication, and so on. And the numbers in the brackets are the standardized residuals from a chi-squared test. Please don't ask me more comments than that. Anything greater than an absolute value of 2 is said to be significant. The statisticians are looking at me. So in study 1, so that's the top graph, the top table, yes, it came out significant barely with p-values, but if you look at the standardized residuals, there's not much difference, except the sequential group tended to comment more so on accuracy than the compare group. The compare group did a little bit more on communication. But there was a lot more noise in study 2 with the larger sample size, and the sequential group commented a lot on whether something was correct or incorrect. The students that were comparing solutions that were similar, they tended to comment on presentation. So a lot of mathematically irrelevant stuff, but also a little bit on communication. And I think what was happening there was the solutions were too similar. So that's an example of one pairing. And a lot of the time the students would just go, I don't know, can I sit on the fence? I said, no, got to make a choice. They go, oh, well, the right one's too messy. Right, that was the only thing they could find that was the differentiator. So I think that's why the aligned pair groups are making a lot of comments about presentation. And then the misaligned pairs group talked a lot about what strategy was used. And again, I think the solutions were so different that they could actually get into like the weeds of what approach was used. I also had a look at the difference between the 2 pairs groups. And no, I'm getting onto that next slide. The takeaway for you guys, if you are teaching and if you wanted to use, say, worked examples in your class, is that I don't think one approach is better than the other, but the way you present is going to shift the students' attention towards certain types of characteristics. So maybe if you're thinking about procedural fluency, you might want to present worked examples one at a time because you're more likely to look at what's right and what's wrong. If you're wanting to get students to think about how they communicate their work, you probably want to present worked examples together as pairs that are quite similar. And if you want them to compare and contrast solutions, you might want to present worked examples in class that are quite different. So I'm going to now sidestep onto something a little bit different before I look at the positive and the negative comments, because this was super interesting. Do we know much about refutation texts? Okay, we've got some no's. So this is typically used in science education, particularly in textbooks. And basically refutation texts are a tool and a teacher approach to fix up misconceptions. They work on the top right, and the yellow is an example. So you start by saying, make an explicit comment about what is the thing you don't understand. So ostriches stick their head in the ground. And then you must explicitly state that is wrong. Then you provide the correct information to replace your misconception. There's some interesting research on refutation texts with box and whisker graphs that have been quite successful. Now, the idea there psychologically is that it relies on this process called co-activation, where you have the correct and the incorrect information in your head at the same time. And it means when you come up to a similar problem, the incorrect information gets dampened down and you might be more likely to now use the new correct information. So hold this in your brain. as we now look at students' positive and negative comments. So, study 1, these are the same stats in terms of standardized residuals. The one at a time group made way more negative comments. The compare group, way more. The compare group made way less negative comments. But this was huge. The sequential group made more than twice as many negative comments than either compare group. And the compare group just made way more positive comments than the sequential groups. And I had a look at the two compare groups against each other. They made the same number of positive and negative comments compared to each other. So it's definitely got something to do with the comparing process. That brings out whether you're going to focus on positives or negatives. Now, I've got these two examples of two students with their think out louds. And it's not that the compare group doesn't make negative comments. They do. So I just want to compare these students. The first one's Adeline, doing one at a time evaluation. And so they're going, they did a very long way, bad. I feel like I don't really understand why they drew the number line, bad, because it's not really important to the question. And it's not simple enough. I don't think they understood this question is meant to be the most simplest, most efficient method. It's just bad, bad, bad. Grace. So she's comparing two problems. Okay, I think these are very similar, except the orange one didn't draw a number line, so that's bad. So I think the pink one was better at communicating because they actually showed the number line. So we've said a bad thing and then said what you should have done to compensate for that bad thing. And I think what's happening here is the compare groups are still saying negative things, but then they're saying what you should do instead of the negative thing. And it's kind of that co-activation process from refutation texts I was speaking to. And I think this might be a big reason why so many studies are finding positive outcomes from using comparative judgment. So I've situated, these are all the studies that have looked at whether students say positive or negative things, put them all in a table. And looking at the groups that say positive feedback, the comparative judgment students will either say the same or more positive comments than the sequential group. And in terms of negative feedback, the comparative judgment students will say less or the same as a sequential group. So it seems to be sort of consistent across all these studies. So I think I've said all of this, but on the left, you just might want to think about how are you going to present your worked examples? If you do them one at a time, it's going to focus students' attention to one sort of thing. And maybe if you wanted to pair worked examples or do peer assessment, it's going to shift their attention somewhere else. You might want to think about what are your learning goals. Now, one thing that I have thought about in terms of why are they looking at positive things, the prompt when they had to make a judgment was, which do you think is best? And that's probably priming you to look for good things. Whereas the one at a time group was just give it a score out of 5. So I'd love to redo this study with maybe, which do you think is worse? Or change the sequential group to be like, what things did this student do well? I don't know. And see if maybe that shifts some thinking as well. So in the dying couple of minutes, I'm actually going to get you to have a chat with a partner. What might this mean for you in your class and your use of either peer review or worked examples? Might this change the way that you present worked examples? Do you just write one up on the board and then rub it off and then put the next one up? Or maybe do you have the technology to have 2 worked examples up at the same time? So I'll let you have a quick chat. All right, we might wrap up there. And Jess is going to get slowly set up. Does anyone want to shout out any thoughts? Very happy to have thoughts. Bear in mind, I have finished my PhD, so criticisms. I don't want to hear them right now. Right. Cool.
You said you wanted to do a follow-up study, so is another PhD out of the question?
Clemency's put some really bad ideas in my head, and I do have a follow-up idea.
Pathy? Jen gave these questions to me a couple of years ago, wasn't it? And asked me to choose between, I was part of that initial comparative study, I think. And yeah.
Some of you have contributed.
It made me think, that's for sure.
Yeah, just a quick response. If you're giving them sequentially, I think the order in which those are given could be important. So
Absolutely.
My preference is to see it together as a pair. That's my preference.
It's just not
for the students,
done in
yeah.
classrooms. So just something for you guys to think about, that if the preference is pairs, you don't often see that. And maybe we've got like double screens here. Could easily have one. And the more explicit you are as a teacher about pointing out the similarities and differences between the worked examples, the better the learning. Is it short, Don? Was that a question?
I was just going to say it. London gave a talk to us at UNSW last week. Yeah. Anthony Cronin gave a talk to us at UNSW last week. He's doing something along these lines with second-year linear algebra students. So they're in groups of 5. They first of all compare pairs of assignment questions. They have to do between 3 and 10 pairs. Then the next stage, they were giving a mark to each of the pairs. And then the final part of it was they had to write something back or write a critique of the answers. And the thing that he found from it was that those students, whether that affected their marks, I don't think he was quite sure, and he hasn't published anything on this yet, but what he found in the final exam, there was a question typically in the final exam which was unseen material and unseen proof. And prior to doing this, almost none of the students would do that question. After having done that, a lot of the students attempted that unseen question. So whether there's a connection there or not, I don't know, but just an observation.